of a challenge, I suggest you close this solution and try to do it on your own. But if not, that's totally fine, because it's thinking through production of this that's really going to be helpful. So let's get started. And first, we'll stem this graph from DS-COVID. We will also focus for the time being, filter on those countries in a given focus. So it's a little bit faster and we can properly focus on it, and we'll change it later. And now we're ready to plot. So ggplot, we would like to map our X onto date, right? So that's we can use this view as the prototype of the graph that we want to create. And then we want Y to be, let's say, just number of cases for this, in this case, right? And next we need to add geom line. And that probably is the only thing that we need, but probably not. So I am selecting lines 59, 64, and I'm pressing Control R to run this selection. Oh, I misspelled case. It's cases. And now I want to want to run the same lines. So I can, again, select line 59, 64, and run it. However, there's a very useful hotkey that you should be aware of, and it's Control-Shift-P. P standing for previous. So it will rerun the previous selection in your source, so that you don't have to reselect it, and it really speeds up your workflow. So let me do just that. Control-Shift-P, and I run the same selection, but now the selection contains updated script, and I should be able to see the plot. The plot looks a bit wacky, and that's because it thinks that it's one single observation. It doesn't know that we need to draw one line for a country, or we need to group it by the country. So we need to add another aesthetic, a grouping aesthetic, that we map it onto either country code or country label. Okay, and again, Control-Shift-P. Okay, this is good. So we got only 6 countries in our focus. I wonder if there's any guesses what this big the line that stand out. Any guesses so far? In terms of number of cases?
The US.
The US, yes, you're right. So okay, so we got the basics, the bare bones plot ready. So now the question is, how do we go from here to this? So there's this really cool package called Plotly. Plotly, in fact, is a JavaScript library. They have the implementation for both R and Python. But the package, the really magic function that is going to really simplify your work in creating this interactive visualization, this ggplotly. So let me show you. If we take let's create a new object. So let's say it's going to be G1P, P standing for Plotly. If we just do Plotly, ggplotly, and just pass this G1 and print the G1P, that already will create a dynamic or interactive view. So like if you hover on it, it will give you the tooltip with everything that you map in it, or whatever that is by default here. That already goes some way, because in some ways you don't want to create elaborate visualizations, you just want something quick. But a way to transform this is to add 2 more things to it. Well, first of all, we need to, before we plot, we want to add the highlight key that will tell us what needs to be highlighted. So we do this before we start building the plot. And then we want to add the Plotly highlight. And I'm giving you some functions here that with the description of what they do, right? So this is adding highlight. right? So this allows us to modify whether it should be a click or a hover. So if you can change this to hover, and the line will highlight if you just hover on it. If you want to click, you leave it this way. And some other options that you can explore on your own. Okay, so by default it's set to Canada, but we can click on this and this gets us US. We can also maybe change this from focus, or just remove focus altogether and look at every country that is available. Right, they give us quite a mess. Probably not very visible. Again, US really stands out by the sheer numbers. So maybe if we add a log to this cases, we will see a little bit better. But again, we're not going into, we're not focusing on interpretation of the patterns, just on the technical aspects of being able to explore the patterns like these. So yeah, that's much better. But again, there's so many countries that this function of filtering, which is implemented by this option, comes real handy. Okay, any questions? Let me pause for right now. Any questions on this section before we move on to the next goal?
Hi, Andrea. Just one. You mentioned the use of that the redirect. What looks like a redirect, using it as a pipe, the percent greater percent.
Yes.
On 78, you've got, well, it starts on 79. You've got a pipe, and then another pipe on the line below, and then another one on the line below that. Is it doing those things sequentially?
Yes. Thank you for bringing this up. Yes, this is. You can substitute the pipe for English word and then. So it basically says, make G1 to be equal to this object, and then filter only those rows for which OECD is true, and then add this statement, and then make the ggplot. And when you get to ggplot, we use pluses, and it's a separate topic. It meant to be as a pipe, but it's just the pipe was not invented when ggplot was invented. So yes.
Okay. Yeah.
Pipe means and then, and it's basically takes everything to the left of the pipe and pass it as the first argument into whatever comes after the pipe.
Okay, no, that's great. Thanks.
Okay, so let's move on, and let's move on to our second goal, and that goal is to create this type of graph in which we can see the relative temporal anchors for each country. And this is really the most probably useful stuff from this workshop, because there's a lot of tutorials on creating visualizations, but it's the data processing that gets usually gets quite hairy. So let's look what we need to do. First, let's travel to the overall solution. So this is the final solution as applied to the COVID data that we have here. If we run it, it's might look quite scary at this point. So don't worry, we'll learn how to decipher this and make sense of all these instructions with a simpler example. For right now, let's just see what we're trying to accomplish. We're trying to compute the already recognized number of cases, number of deaths. So we want to compute the cumulative running sum for number of cases and deaths. We want to get this adjusted for population, which is fairly easy to do. We have the population data. We want to compute how many days passed before, after the first case to the current date in our observation. The same thing for the number of deaths. Maybe compute some alternative timelines that will be the same for all countries. So there's the number of days since a timeline, a landmark like Exodus, the first case outside of China, or when the WHO announced the pandemic, and maybe create dates that identify what was the date of the first case, what was the date of the first death. With those variables, we can really be quite flexible in exploring these data. So that's the end result, and we already started it. You should be able to run the script, but again, the focus is on understanding what happened here and how to do it yourself on similar projects. Also consider this. When we have, let's look at the sample data that I've created for this demonstration. We're using the example of the first confirmed case as a point of interest, but we also may want to think of, well, maybe what is the date of 10th confirmed case? That's a frequent operationalization of the start of the pandemic, or maybe 5 deaths in a row, or some other ways to define what is the day zero of that country. So it will pay off to be flexible. So let's look at this very, very simple case and walk through the steps of how to work and compute these relative timelines for individual countries. We have 3 countries, fictional data, number of cases of something. And we have, for Albania, we have NAs starting in the first observation. For Botswana, we have the NAs in the second temporal observation. In Chile, we have no NAs, and we have observations from the get-go. We also see that the dates are different, and this is done just to simulate a variety of scenarios that we may encounter in the data. So when you embarking on a task like this, it really pays off in the long run to construct a small data set on which you can develop all your logic, all your scripts, and then transfer to a larger one. It's usually it saves us more time in doing that instead of having to go back and correct for mistakes of which you may not be even aware in the first place right immediately after you run it. So this gives you a much higher probability that you know in the validity of your scripts. So here's our data set that we will develop our scripts that we will transfer later to the real data. Okay, so here's the solution. Here's the final solution for this. Let's look at it and what needs to be done. So here's we have the same observations. We want to create a cumulative number of cases that would count. And again, the benefit of this small data set is we can manually inspect and count to make sure that these computations are correct. So we have one column that runs that sums up the cumulative cases for each country, and we see that it counts correctly. We can verify it manually. We have the date of the first case. So for Albania, the first case was March 3rd, and here is the March 3rd. This is the same value for all rows because this is a unique value. For Botswana, the first case was April 3rd, so we have April 3rd. Okay, that's correct. And for Chile, it was May 1st, so the very first date in the data set. Okay, and days since first case, this is marked as 0 because yes, that's the first date. This is marked as 0, and we see, yes, this is the first date that has a non-zero count of number of cases. And for Chile is May 1st. Okay, so we know what needs to be done. Let's see how we would approach this problem in real life. So here's the sub goals that might be helpful for us. Let's just take the starting of this code. Right, we want the reprex timeline. Right, so we want to create a new data set from this vreprex, reprex standing for reproducible example. And we will be creating this we'll be doing these operations for each country. So it internally subdivides this data set into individual data sets, in this case, 3 individual data sets, and does all the operations within the data set, and then moves on to another and to another until it exhausts all groups. So we want to mutate, we want to create a new variable, and our new variable would be n cases cumulative. And a good, this is very ubiquitous function, cum sum, right? So it's a cumulative sum of some other variable. So let's say it's a cumulative sum of n cases, and let's run it. first of all, make sure that we ungroup it. It doesn't matter in this example, but you don't want to inherit the grouping parameter when you pass this data set to further down the analytic workflow. So ungroup, and we want to print this data set because we can. It's a simple one, so we can understand what that is doing. Okay, we see that there's an error. It gives us NAs where it's supposed to be counting. And the reason is because if it encounters an NA, it just breaks for the rest of that group and it produces NAs for the rest of the group. So a good way to remedy that is to put this N cases, convert the NAs on the fly. So we use the tidier package called replace NA. And whenever it sees an NA in this case, it will replace it with a 0. So, and we again repeat Control-Shift-P. Now we got N cases, it's run just fine. Okay, so we got the cumulative cases figured out. Onset marker. Again, I'm gonna go in simple steps so that there's a transparency of what's happening so you can check it very easily. You may find it a little bit simplistic at times, but that's okay. Simple is good. We'll complicate it later. So next, we would like to create a single column that would mark whether this value is greater than some arbitrary threshold that we identify. So let's call this onset case, and that is because we define what is the onset of epidemic based on the number of cases, so some arbitrary threshold number of cases. So whenever the number of cumulative cases cumulative is going to be greater than 0, we'll place it as, it will return a true value. So let's run it again and see whether it does it. Yes, so it false. The first time it sees a non-zero value, it puts true, and it's a true for the rest of it. Again, false. The first non-zero value is true, and for Chile, it's true from the get-go. Okay, so we have accomplished the onset marker, right? We can later replace this 0 with either 10 or 30 or some more complex expression, but we know how to do it now. Okay, next, we would like to create a first case marker. So in this case, we want to only the first encounter of this. So let's identify the row that breaks that pattern, right? That exceeds the threshold. So to do that, we can rely on the a useful feature of the logical characters, right? So when evaluated mathematically, false is equal to 0, true is equal to 1. So if we take the running sum of this, right, it will create a, let's do that. Let's create a running sum of this onset case. So let's create a variable, well, let's call it date of first case. Yeah, date. Okay, so hold on a second, what did I call it? First case, yeah, that's first case, right? And we'll take a cumulative sum of onset case, right? And run it. Nope, onset. Yeah. So we'll see that it starts and then it starts adding with ones and zeros and start adding them up, right? So we're interested in the row in which this value is equal to 1. And that's how we can get the row that corresponds to the exceeding of that threshold that captures the row that we're interested in. So let's say that we'll do, and now what we want to do is add a new variable that would capture. So we've done this first case marker. It's whenever it's equal to 1. And now we would like to extract the date of first date, which is quite straightforward to do. Now, so date of first case, and that date of first case is going to be equal to the case. So if else, if else, if this first case is equal to 1, it will return the value in the date. Otherwise, it will just return an A. Let's see that. We need to expand our view just a little bit. See that? Yes. So right now it transforms it into a numerical case, or we can rectify it by adding lubridate s date. Okay, so now I know that this is matching. This is matching. Good. And now, well, actually, we don't need those NAs. We want this to be the same value for all the rows associated with that country because it's a single value. So what we can do is we can just override this definition and just take the minimum or maximum and fill it in. So date of first case equal, let's say, minimum, or you can use maximum and just write any date of first case, and that will fill it in. NA remove equal true, and that will fill it in and make it all values to be the same. Okay, so we've computed the date of first case, and now finally we can compute the duration, right? So we are interested in how many days have passed between this date, the date of current observation, and this date, the date of first case, right? Now this computation is trivial. We say days since first case equal to date, that's our current date, minus date of first case. Okay, and run. Again, we need to expand it more to fit it on the screen. Here we go. Again, this returns it as a not a numerical value, but a date format. So maybe we just add as integer here to use it as a regular numerical value, and that will just return the value that we need. Okay, so final touch, and that is re-expression of this in a more succinct way. Right now, we don't need all these variables, right, to be left in our code. We can do it much more succinctly. So let's look at it and just recognize these the sections. So here's our cumulative sum, right? We've computed it, no change here. But these sequence of operations, we can easily express as a single sentence. So first we run whether the number of cases cumulative is greater than 0 or whatever the threshold is, right? That returns a numerical value. That returns a logical value. Then we see whether this logical value, the cumulative sum of that logical value, is equal to 1. That's how we captured the first occurrence. Then we extract that row from the other variable called date, otherwise place NA, and then we make all of them to be the same for a country, and then turn it into a formal date, right? And here we compute a relative timeline. So I would probably keep this solution as well in my code. I will just maybe just turn it off and keep only the solution that I end up. But if you have any mistakes or questions later on, it's much easier to go and verify that or walk through the logic of computation here instead of trying to disentangle this expression. But if you're good and if you're very familiar with these things, maybe brevity is more advisable. So finally, let's look at this this application of this script to the real data. You already recognized this. Here's the section almost verbatim from our solution, right? First, we compute the cumulative cases, then we compute the date of the first case, and then we compute the relative timeline. So this section is almost identical with this section with only exception that it deals now with number of deaths. And it's as easy as replacing number of deaths to the variable and cases to variable and deaths, and assuming that the logic of capturing the temporal anchor is the same. We just want to find the day that on which the number of deaths cumulative became non-zero. We can just replace the variable names. Now it's much more straightforward to in fact, it's not related. We just create a parallel dates for data since Exodus and dates since pandemic, and create a population-adjusted values for both a number of deaths and number of cases, in case we want to explore the relationship with those values. All right, I see that I'm running out of time. So let me quickly jump to the visualization now that we can create this. So here's again, I'm created the final product that we want to create. Now that we have these data points handy, right? And let's real quickly look at the essentials for this graph. So a good approach is to first get the most bare essentials of what makes this graph what it is, and then add aesthetics to play with this. So let's identify what is absolutely essential. This is what is absolutely essential, right? So we want to create a line. We can use it as sub goals, right? So we just create all lines together. We create a D1 that is a subset with this focus. We create a, this is, sure. We have, this is just, it's the same, this is rudimentary, we don't need this. So the X would play day since Exodus. This we could have used date. But this we have a more operationalization here, and add just the geom line. So let's see what that looks like. G2. Okay, so day since Exodus, we have all lines on the canvas. So if we want to spread them apart, that's easily done by adding the facet component, facet wrap. Right, for the country, rerun it. That places it in facet wrap on the country label, so we can read what the countries are. Okay, and if we, again, because it forces it all the countries onto the same scale, we can use scales, scales equal free. That will free up and allow us to evaluate the pattern within each country on their own scale, and see that scales change. But now what we want to do is to add this dot. We've computed the date, right? We computed the date if we run just on a different, more generic scale. We computed the date on which there was a first either case or the first death. So how do we add that dot, one single dot, to this plot? Like intuitively, you would say, well, let's just add geom point to this ggplot, and that should do it, right? Well, not really, because it will add a lot of points, right? It will because it has a lot of data, because it's mapped onto the date and number of cases. So what we want to do is we want to filter this data to limiting only on the date that we want. So if we want to select only the days that has a particular marker, right? In this case, let's say days since first case equal to 0 or equal to 1. So for us, we have D2 because this is our filter that we already filtered those countries. D2, filter days to days since first case equal to 0 or equal to 1. We run that, and that places a single dot right here. In a similar fashion, we can add another geom point with a different filter. And that, let's say, is going to be the day since first death. And that will place a second marker. And again, this is possible only because we did spend time on computing those values in the first place. So maybe we can change the size, something very quickly to differentiate it, the first from the second. So we can see and we can start adding more aesthetics to help us understand how to interpret this particular pattern. I see that I'm running out of time, so I would like to leave some time for questions. As I said before, I've created a narrated version of this workshop in this blog post that you can check out. I walk through the same steps, and you can explore it on your own time. I demonstrate all the examples and with an annotated code, so you can use to see whether these solutions could be transferred to the projects that you're working on. If you're interested in cross-country comparison of COVID data, please let me know. I'm currently working on several projects that does it. And with that, I will pause and see if there are any questions, comments, or discussions points that we may entertain.
Hi, Andre. This is Gary Domslar. So I wanted to say thank you for giving this this workshop. That was tremendously valuable information that you've provided. So I mean, at the National Microbiology Laboratory course, you know, very centrally involved in surveillance of the coronavirus outbreak, and you know, I mean, surveillance is stripped down to its essence is monitoring information over time. And so, you know, the ability to be able to visualize these trajectories of these critically important variables that we are monitoring, you know, it's super important. So this is like stuff that I can see we could be using directly at the NML. And have some plans basically to do so. Also, in my talk on Thursday, I'll show you how the work that you're doing is being applied for surveillance. Yeah, so that's all I wanted to say. Thank you. Oh, but also, and this maybe is a question for Allison, are these being recorded?
They are being recorded, yes.
Yeah. Perfect. Okay, good. Thank you. Also, Andrea, at the start, I think, do you have a link that you can provide for the, like a GitHub link or something like that? I think you showed something.
So that GitHub link is in the program, the beta program.
Good. Okay.
I also shared it over the chat. Let me double send it.
Okay. Yeah, but Jeff, you can send it on the chat, or if you've done so, then I can grab it from there. Thank you very much.
Yeah, it's on my GitHub page. So GitHub and COV, that's my GitHub username, and it's one of the pinned repositories. So
copy that.
Okay. Thank you. Thank you for your comments.
Yeah, thank you so much, Dr. Kobal. Is there any question from other sides? Yeah.
Hello. Hello.
Yeah.
Can you hear me?
Yeah, please, Aaron. Yeah, I can hear you.
Okay. I have a question for you, actually. First, I'll say thank you for the tutorial and guiding us through everything, because it was actually really, really cool to see how you did the data analysis and all these sort of advanced features you're using. And actually, one question I have is, how did you make the like tutorial or walkthrough you have? Because I noticed it has a bunch of interactive features as part of it.
Yeah, so one of the benefits of downloading the entire repository is because you get to see this. So if you do that, there's this analysis folder within the repository that has the COVID trajectory report. And this is actually the report that I see that I refer you to in the video. So it's a pair of R and RMD file. They are used to produce an HTML canvas that you see that you can host. So to give you an idea, Here's I'm opening both files, right? And this is the source file that contains the R instructions of what needs to be done. And this is the RMD file that compiles it into an HTML canvas. And they're connected by, well, right here it says a read chunk from this R file. So when they're connected, they look at the names of the chunks and use that to connect. So I can enter text here, and then I enter the name of the chunk, and it will go back to this R file and run the file associated with this chunk. So it does it. So I can interleave the human commentary with the R commands and create this nice looking report that sort of helps you to create a more narrative style of your reporting. So for analytic reports, I find this to be very effective ways to deliver information to people who are not necessarily technical. So check out this RMD options. I particularly like this collapsible code feature that can hide all the stuff that you don't want your non-technical audience to overlook, but yet have access for those who want to reproduce this. Did that answer your question?
Yeah, it did. Thank you so much. I didn't realize it was an R Markdown file. I haven't really used that too much, but it looks really neat what you did.
Let me know if you need help. I'll be happy to show you more.
Yeah, thank you. Yeah,
Okay.
thank you.
Yeah, Walid, I think we'll close off now.
Yeah,
Go ahead.
exactly. Yeah, exactly. Because Lisa, do you have any comment or question about this session?
No, you can just close the session off, Walid. Thanks.
Okay, thank you so much, Dr. Andrea, for your tremendous support and time. We have learned a lot about the longitudinal data visualization in R, and I'm grateful to you on behalf of the Bhadar Summer School. I want to thank you, and if anyone have any question or query, we will let you know and contact you later. Thanks for your report and time. Really
Thank you.
great presentation. Yeah, thank you so much.
Thank you. Looking forward to hear from you. Bye-bye.
Yeah.